Yeah, so hey, my name is Kashvi Nitin, and my project was titled Modern Baseball. And basically, it was just like a data-driven approach to forecasting used in Astros game outcomes. So a little bit about myself. My name is Kashvi, and as you can obviously tell, I'm an Astros fan, and so I'm from Houston, Texas. And I'm a current senior. A little bit about why I chose to research this project, in part because like I'm an Astros fan, but also I knew that I wanted to create like a machine learning model that's like capable of like predicting future games. And baseball just seemed like the sport to do it on, because it's like a lot better. Like it has like more predictive analytics. Like it's very metric based. It's very data driven. And so if any of you guys have seen like the film Moneyball, it's a great film by the way. But it kind of explores like how baseball, like how sabermetrics came around in baseball, which is just like taking like one particular metric and like optimizing it. So in this case, like the Oakland Athletics, they were like cash strapped, like they didn't have as big of like a budget or like a payroll, but they just focused on base percentage, which is like the percentage of times like a player reaches base, to like get like players that like other teams like may have passed on for other reasons. And so about my project itself, the first thing we wanted to do was define the problem. So like, what's the goal? And do we want to focus on the Astros in general, like create, or like do we want to focus on the entire MLB? Because if you create a model that's like Astros-centric, it will be really good at predicting like Astros games. But if I wanted to like translate that over to like another team, like one of my rival teams, um, then it would fare a lot worse. Whereas if we chose to do one over like the entire MLB, it would be it would be like good at like predicting like in general, like any random team, but like its accuracy for like predicting Astros games would not be like as great as like predicting as like the first model. And so in the end, we ultimately decided to focus on the Astros because like my goal was just to like accurately predict Astros games. And so that led to the formulation of my research question, which is just like what metrics have the most significant impact on the Houston Astros' likelihood of winning a game. Okay, so a little bit about data collection, because like machine learning may not be something that everybody is familiar with, but similar to like a research paper, like a machine learning algorithm needs to have like past data, like historical data, that the model can like train itself on. And so like a research paper, you want to use like data that is like fairly recent, that allows it to like train itself on like the most accurate data, and formulate like the best conclusion. And so for us, we chose to focus on like the last three seasons, because like once again, or like a baseball season is very long. It's like 162 games. And so if you just focus on the last three games itself, like you have like around 500 games that you can like use as like a training base, which is a lot. Okay. Yeah. And so we also decided that when we were collecting data, we would take the moving averages of a team, instead of like static averages. So static averages would be like if like the season before, like the Astros had like a 200 average, for like on base percentage, which is like really low. Um, but like you would use that for like every game in like the upcoming season. And so as you can tell, like that's not very great because it's not indicative of like where the team is presently. Because like this once again, like the season is so long. And so like you have a ton of injuries, like people can go on hot or cold streaks. And a moving average is like once again a better indicator of where the team is presently. Um, and also, like as a team sport, we realized that it's more important to focus on the team part rather than individuals. And that's why we elected not to focus on specific players or like pitcher matchups. And then the last thing that we had, or like the last problem we faced, was like, how do you account for the fact that the Astros are playing a different team? Because if I just compile data on the Astros itself and I don't focus on their like opponent, then I wouldn't really have a very accurate model. And so two possible solutions we came up for this was to have one data sheet for the home team, and one data sheet for the away team, and then just compare the two. And then the other solution was just using differentials, that is like taking like the Astros moving average for like a certain metric, and subtract that from like the other team's moving average. So we chose to use differentials because it would let us just have like one consolidated data sheet, which would make it a lot easier when it came to training the model. And then so as for the data itself, the sources that I chose to find the data from were RetroSheet and Baseball Reference. So RetroSheet is like this historical baseball archive. It houses data on like past baseball seasons. But because it only houses data on like past baseball seasons, I had to go to Baseball Reference for like the current season. Okay. Yeah, so data collection was actually like the hardest part, which is just like collecting the data and like reformatting it. Because like the data that I had before, like this is like an example of how it looked like on RetroSheet. As you can see, it's just like it's like just like strings and strings of like the game, like of like stuff that like doesn't really look very usable. And I had to like go in and like manually like format like 500 like games plus because I had to do this for like every team. So like I had like 500 games per team times like the 32 teams. Um, but yeah, so this is how it looked like at the end. So you can see that I have like a game code. So like this first row, that's like the second game of the 2023 season. Like metrics such as like if they're a home or team, if they're like the home or away team, if it's like a day or night game, if they win or loss, like the score differential, and then like here are like your metrics that are like your moving averages and like the differentials between like the Astros and their opponent. And then so now that the data was cleaned, it came to like actually training the model, which is like taking that data, putting it into like an algorithm, and then like just training it and then testing it. Um, but before we could do that, we just wanted to see if any variables had any correlation. Just because like if there were any variables that like weren't very correlated, you can like exclude them from your model to make it more accurate. So one of the first things we did was we made a heat map, which is just like a great visual of seeing like things that have a high level of correlation, or like even just things that have like a very low level of correlation. And so some initial observations we made was that seemed like some good indicators would be like the strikeouts that like batters face, the earned run average, and the score differential. And relatively unimportant indicators were like if the game was a home or away game, like how many times a player was like hit by a pitch, or if it was like a day or night game. And so from there, it was trying to decide which type of machine learning model we would use. So typically, like there's two ways that you can do this. You can kind of like intuitively decide which model to use, or you can use something called Lazy Predict, which is basically a package that you can install. And it just like brute forces like a ton of different models and see which one is best. And so we chose like first, like just like intuitively like figure out which model would be best. So here's like the cheat sheet that we used. Um, so we knew from like the start that we wanted to like not really like reduce any dimensions. And we didn't really want any responses. Like we wanted to predict like numeric values. So we knew that we had to do like a supervised learning model. And because we were focused more on accuracy, we chose like the random forest like regression model. Because like classifier models work better when you have like um when you like don't have like I guess like as like numeric values. Or like if you're trying to like focus more on like simple like boxes, but like in baseball, like typically like your outcome is like the score, right? Which is like different numbers. So we don't really have like any two like binary outcomes. And so we also, after we decided that like a random forest model would probably be best, we just ran like lazy predict to like kind of like um I guess like evaluate like our prediction and like just like see if it worked. Um, but before we could do that, we needed to define the x and y variables. So your x variables are like all of those like columns, like those moving average differentials. Whereas our y variable was like whether it was like a win or a loss. Um, and then Lazy Predict also requires training and testing data, because basically what it does is it takes like a certain portion of your data, and it uses that as like the training data to train the model, and then it runs that to like try to like on your testing data, like try to predict an outcome, and then based on that accuracy, that's how it decides like if that's a good model to use or not. And so it would be very hard to like manually split it, but we just use train test split, which is um just like a quick thing that like will split your data into training and testing data. Um, and so what we found was like a little bit surprising, because we found that classifier models perform better than regression models. And that's like it was very surprising to us because we thought that, oh, baseball is like a very metric-based sport. Like we're trying to find like the score, which is like a number. So like why are classifier models working better? And our regression models were also performing like way, way worse than we expected. Like they had negative R-squared values. And R-squared values are typically supposed to be like 0 or above because an R-squared value like tells you how much of like that, what percentage of the data can be predicted by like, or like the variation in that data can be like accounted for by your model. And so like the closer the values to 1, like the better the regression is. But our like it wasn't even 0, it was like negative. And so we had to do some adjustments. So the first thing we did was we scaled the data, because some columns in our data table had like higher values than others. And so we scaled them so they were all like on like the same scale. And we also added in another Y variable was the score. Because initially we just had like a win or a loss, so we had like a 1 or a 0. And that makes it easier to calculate for like regression models. Um, yeah, but once we ran it again, we still saw that regression models had negative R-squared values, which again means that it's like very, very bad. So we began to experiment with other variables to set as our Y variable. And we saw that predicting the run differential saw great results. And it had a 0.97 R-squared value, which means that like 97% of like the variation in like the run differential can be explained by our model. So then we had like this one question, right? Because yes, great, it's awesome that we were able to predict the run differential, but that's not telling us whether the Astros were winning or losing. And so we had to like we came to the dilemma like how can we use this run differential to calculate whether the Astros win or lose? And so two possible options were to like compare it to the game before it, and then if it increases then the Astros won, and if it decreases the Astros lost. So when we trained the model using this method, it had an accuracy of 67%. And another possible way was to just reverse engineer it. So like since we're taking averages, if we know what the current game is, like where it falls in the season, we can calculate what the score differential of a particular game was. And then we can use that to determine whether the result was a win or a loss. So like say that the Astros average after game 2 is like 2 runs, and after 3 games their average is 3 runs, then the number of games scored in game 3 is 3 times 3 minus 2 times 2, or 5. And so once we trained the model this way, we had an accuracy of around 70%, which was better than the previous method, so we just chose to use this. Um, and so for conclusion, and the ultimate conclusion that we came up with was that even though like we have some areas of future improvements, like we can create models for all 30 teams for like greater accuracy, and we can probably figure out like a better formula to translate run differential into a win or loss. 70% or like being right 70% of the time is still like way better than like current like sports betting odds, right? Like if you've ever seen like if you tell somebody, oh, like 70% of the time when I gamble, I'm gonna win, like that's insane, as opposed to like the 50-50 odds. Um, and then so it's not only like applicable to sports betting. You can like use it like in like just like novice, like the casual baseball fan, can use it in other activities. Like they can use it to figure out like which players they should choose for fantasy baseball, like which team they should use. Or like if you're a fan and you want to know like how your team will perform in the season. Like it's good for that as well. But yeah, thank you for your time.
Awesome. Thanks so much, Kashvi. I feel like I'm learning a lot more about baseball today. So question for you. Do you think that a team like the Astros could actually use this type of model to make game day decisions? Like how would you advise them to use something that you've built like this?
Yeah, I definitely think that they can use this model to like make game day decisions. I do think that it may have to be like configured like a bit more, like maybe instead of like having like your X variables be like these statistics, you can focus more on like player statistics. And then when you compare them with like the projected like lineup of the other team, you can like figure out which players like you should keep or like not keep in the team. But like also like if you just like run like your average and see that, oh hey, like it looks like we're losing this game, maybe that's a game that you want to like focus more on. And like maybe like you want to address more of your resources to like seeing, oh, like what are possible adjustments we can make to make our team better.
Awesome. Yeah, that makes sense. There's a lot of variables here at hand. We actually have a panelist who wants to ask a question. So I'm going to ask Marin to unmute. Marin, can you hear us?
Sorry, I thought I unmuted. Um, I was wondering, because you have a lot of different X variables you were using,
Mhm.
what was your strategy to avoid overfitting the model?
Oh yeah. So what we did is that well, I don't have it with me right now, but what I did is that I like calculate like I said before, like I saw which variables weren't like as like helpful, like the ones that were making more noise and they weren't like helping. Like I used that heat model. I also saw like which variables weren't really contributing anything. And so we excluded those variables from our X variables. So we like some of the variables that we eliminated were like if they were a home team or an away team. Um, like the on base percentage, like the slugging percentage, because like surprisingly those weren't like good indicators.
Awesome. Thanks for answering that. I have one more question. So it sounds like you had so many different tests and you kept iterating over and over. What was your biggest aha moment while you were making these adjustments? Like, do you remember one of the most impactful ones?
Yeah, definitely like the last adjustment we made, like when we were like testing, like maybe like we want to see like how we can predict like if we can change the Y variable to have like a higher like predicted value. And so when we finally put like that like predicted like run differential and we saw like a very high R squared value, I'm like, uh-huh, like that works, like that's great.
Awesome. That's such a great feeling. I've done a lot of these types of projects, and it's always nice to find some good results. Awesome. Thank you so much, Kashvi.